Let's get ready for the countdown.
With the current world population grid today is 7.5 billion people in the entire world. Majority of this population are using computer. We cannot deny the fact that we find them everywhere in the useful all kinds of different tasks. We can find them in schools, homes, offices, businesses, shops, banks, and even cars. But do they wonder if what is the computer architecture of the computer system they are using today? Welcome to the Neumann Architecture tutorial. Let's define first what is von Neumann architecture. The von Neumann architecture is also called as von Neumann model. It is a computer architecture uses model for designing and building computers. It was publicized by the Hungarian physicist and mathematician John von Neumann. Von Neumann architecture has the following characteristics. First, it consists of three hardware systems, such as central processing unit, main memory, and input and output system. This is the non-modified von Neumann architecture. The central processing unit, which controls the operation of the computer and performs its data processing function. Inside the CPU, we have the program counter register that holds the address of the instruction to be fetched next. We have also register that provides storage internal to the CPU. Next, the arithmetic logic unit, which performs the computer's data processing function. And also, we have the control unit that controls the operation of the CPU. Our second hardware system is main memory that stores data. The input and output system that moves data between the computer and its external environment. Second characteristic, program is stored in memory during execution, or it is a stored program concept. Program is stored in memory during execution. The von Neumann machines are using a stored program concept, wherein during the execution of every instructions, the program is stored in memory, which is the random access memory. Last characteristic, program instructions are executed sequentially, meaning in every instruction that is being processed by the central processing unit are following the step-by-step order of the process. Therefore, during execution, no jumping in the sequence of steps for the whole execution of the instructions occurs. The ideas present in the von Neumann architecture have been extended so that programs and data stored in a slow-to-access storage medium, such as hard disk, can be copied to a fast-access, volatile storage medium such as the random access memory prior to execution. This architecture has also been streamlined into what is currently called the System Bus model. This is the modified von Neumann architecture. The data bus moves data from the main memory to the CPU registers, and vice versa. The address bus holds the address of the data that the data bus is currently accessing. The control bus carries the necessary control signals that specify how the information transfer is to take place. Other enhancement to the von Neumann architecture we have using index register for addressing. Next, adding floating point data using interrupts and asynchronous input and output. Next, adding virtual memory. And last, adding general registers. The features of the von Neumann architecture work together in the modern computer systems we are using today. And this is how it looks like when these features work together for the certain instruction or data needed to be processed. Welcome to the Neumann architecture execution cycle, and also called as fetch, decode, execute cycle. Let's proceed to non-von Neumann machine. Non-von Neumann machine are computers that refers to the class of machines that are not based upon the architecture of a sequential machine. It consists of more than one, tens, hundreds, or even thousands of individual processors that are collectively grouped together. The processing of non-von Neumann is a computing technique that involves two or more interconnected processors, which can be von Neumann in nature, that concurrently perform different portions of the same application. These are the non-von Neumann computers. We have multi-computer, data flow computer, multi-processor, associative processor, array processor, neural network, parallel processor, pipeline processor, processor array computer, vector computer, systolic array processor, and last, supercomputer. In this presentation, we are going to focus about supercomputer. Let's have the uses of supercomputer. Common uses of supercomputer in industry, we have predicting climate change, testing nuclear weapons, recreating the Big Bang, forecasting hurricanes. Here are the top 10 supercomputer. We have TNK-2, Titan, Sequoia, K-Computer, Mira Blue Jean/Q, Stampede, Vulcan Blue Jean/Q. Here is the summary. Neumann Architecture uses single processor like laptops and personal computers. Non-Neumann Architecture uses multiple processor like supercomputers. Thank you for watching. For your comments and suggestions, you may send at interrupt8080@gmail.com.